MapReduce. So guys, as discussed, MapReduce is the heart of Hadoop. MapReduce is the heart of Hadoop. So agenda for the day is MapReduce introduction, map and reduce phases. These are the two different phases, and what is exactly the map iteration, map concept, and then reduce concept. Okay, then how these two functions are different. Then we are going to see the various features of map and reduce. Then we'll compare both RDMS and MapReduce paradigm. Okay. So let me give you a few definitions. MapReduce is a programming model. MapReduce is a programming model designed for processing large volumes of data in parallel. Okay, MapReduce is designed to process data for data crunching, data processing. We understand, guys, data processing, right? Conversion of data from one form to another is data processing, or we can say this to generate the insights from the data is again a data processing. How much data? Huge volumes of data in parallel. Now how parallel? We understand this also because we already store data on multiple machines. That's why MapReduce will process the data distributedly by dividing the work into set of independent tasks. Now before starting, let me give you one definition, although it will be covered in the next few slides only. The unit of work submitted by the user is called job. I hope all of you are having paper and pen ready with you. The work submitted by the user, or the unit of work submitted by the user, is called job. The work or the job will be divided into tasks. A small tasks. These tasks will be done by slaves. Firstly, the map task is done, then reduce task is done. That we'll see later. Now let me read another definition for you. MapReduce programs are written in a particular style. They are influenced by functional programming constructs, especially idioms for processing lists of data. What is this exactly? The list is, we'll see later. Actually, it converts the list from one form to another form. MapReduce converts the list of data from one form to another form, and MapReduce does this twice. MapReduce does this twice. Okay, let's move ahead. Understand this. I'm giving you a very high level picture of MapReduce, still very high level picture. We'll go deeper and deeper with the next slides. MapReduce divides the work into small parts, each of which can be done in parallel on cluster of servers. Now guys, this is the problem. This is the big problem, that will be divided into small sub problems. This is a very big problem that will be divided into small sub problems. These sub problems will be solved in parallel or distributedly on cluster of servers. And then finally we get the solutions. This figure doesn't mean that all the solutions, all the results will be merged together. No, this doesn't mean that. This means that there is a solution. At the end, we are getting the solution. This all will comprise of a solution. Again, giving a very high picture. MapReduce is highly scalable. Yes, it is highly scalable. We can add more and more machines in the cluster. We can scale our system and can be used across many computers. We can deploy a cluster of say 100 nodes, 500 nodes or thousands nodes. Now, many small machines can be used to process jobs that normally could not be processed by a large single machine. Instead of one big monster machine, I am having hundreds or thousands of small machines. Thousands of small machines I am having. And these small machines are going to perform the job. Now guys, understand, suppose I am having one file that can't be stored within the limit of a single machine. The file that can't be stored within the boundary, within say on the disk of a single machine. Such type of data can't be processed by single machine. That means data that is that much huge, that much large. Or suppose my algorithm is that much complex. The use cases, if you recall, we have seen earlier, like the data crunching was taking weeks or months. Let me take few questions. Is there any specific formula for followed for division or logical division? If you recall our HDFS, what we exactly did in the HDFS, the actual files were divided. The files were divided into blocks, and sub blocks were stored on this machine, some block stored on one machine, some blocks stored on another machine. So problem is divided into sub problem. It means that this sub problem is going to process one part of the data, few blocks of the data. How exactly it is doing that, we'll see in next few slides only. So if you're asking for any specific formula for logical division, the formula is based on your storage only. Out of my 1000 blocks, I am having 10 machines. Each and every machine will process 100 blocks, right? So work is reduced to 10 times. 1/10 of work will be done by the first machine, 1/10 second, 1/3 third, 1/10 fourth, and so on up to 10 machines. Urj, clear? Good. We'll discuss this point in great details. Okay, it's clear. That's very good. Yeah, we'll discuss. Map now. A few more concept of MapReduce. MapReduce is the data processing component of Hadoop. MapReduce is the data processing component of Hadoop. It attains the work of data processing by distributing the tasks across the multiple nodes. Important definition. We understand that HDF is the storage layer, MapReduce is the processing layer. HDFS is the storage layer, MapReduce is the processing layer. Now, how MapReduce attains the work? How MapReduce processes the data? By distributing tasks across multiple nodes. It would be a little tricky to understand. I am having a huge data sitting across the cluster. In the same manner, my data will be processed distributedly across the cluster via running multiple tasks. In next few diagrams, it will be little more clear. Conceptually, MapReduce programs transform lists of input data elements into lists of output data elements. Now guys, as discussed, the input will be the list and the output of MapReduce will be the list. Now the MapReduce program does this twice, using two different lists of processing idioms. That is, one is the map and second is the reduce. Input to a map will be a list, output from the map will itself is a list. Input to reduce will be the list, output from the reduce will be the list. In different map and reduce, there is a small phase called shuffle and sort. So again, just for the information, just for the reading. Now, before going to the architecture diagram where we'll understand the complete end-to-end flow, let's understand few terminologies. Job, usually guys, the work is called a job, the work submitted by the user, or a unit of work submitted by the user is called job. It is a full program. Job is a full program and execution of mapper and reducer across a data set. So just you can understand a MapReduce job, it means a complete program or complete algorithm or complete work, the work submitted by the user. Now, important point, what is a task? Task will be the sub job, the work that will be divided into small pieces is called a task. Say for example, I have submitted a work to master, okay, that is a job. Now master divided that work into small pieces, that is called task. Now task is an execution of mapper or reducer on a slice of data. Now guys, you can easily understand what will be the task. The processing of one block by a mapper can be considered as a task, correct? So my data that is splitted across the cluster in the form of blocks. Now processing of now processing of those blocks, processing of a block can be considered as a task, or means if I give you one map task or a reduce task, a correct terminology, there can be one map task or one reduce task. Task attempt, we'll see later, that is a particular instance of an attempt to execute a task, but we'll discuss later. Okay, before going to MapReduce job, let me show you the complete picture here. Now guys, suppose this is a client who will submit a MapReduce job. To whom he need to interact? He need to interact with the job tracker. Client need to interact with the job tracker. Job tracker run on the master node. Job tracker is the master of MapReduce. He need to interact with the job tracker. If you recall, in the HDFS, client needed to interact with name node. Here client will submit his MapReduce job to job tracker. Job tracker in turn submit the same work to all the slaves. That is, the slaves in the MapReduce is the task tracker. So here it comes job and it forwarded the task. Now guys, although I am saying it divided the work into task, but it forwards the same algorithm. Job tracker forwards the same algorithm to the machine. Now this task tracker will be running on one machine. This task tracker will be running on one slave. Now the responsibility of this slave will be to process the data available on this slave. Understand this carefully, important concept. If you want, I can draw a little bit things for you. Suppose this is a machine. This is my slave. And I am having, corresponding to a file, I am having suppose 100 blocks of the file here. The overall number of files, overall number of blocks of that file was suppose in thousands. And out of which I am having suppose 100 blocks here. Now, what do I mean by dividing the work, logical division of the work, conversion of job into the task, or how exactly my data will be processed? How exactly my data will be processed? Now guys, understand this carefully. In the MapReduce, we are having two algorithms together. First is the map and second is the reduce. First is the map, second is the reduce. Map will process the data and convert it into one form. Reduce will again process the data and convert it into another form. Map provides us a mechanism or place where we can write our own code. Same way reduce also provide us a place where we can write our own code, our own custom business logic. Now, if you recall, in HDFS we had a very large file, okay, a file of size say 100 terabytes. Again explaining this thing guys, understand this, 100 terabytes. So the file will be divided, file will be split into small blocks. File will be split into small blocks, and these blocks will be stored distributedly across the cluster. These blocks will be stored distributedly across the cluster. So few blocks on the slave 1, few blocks on slave 2, few blocks on slave 3. And this will be my master. Hope you can recall this concept of HDFS. Guys, all of you, if you, this thing clear till now, everything clear? If I can get a smiley. Till HDFS, just big file divided into small blocks stored on cluster distributedly. Perfect. So I got all these smileys, perfect. Now, same user came. The user will come and again interact with the master. The user will come and again interact with the master and say, boss, I have submitted a file. I have given you one file of size 100 TB. Even it will not say size, it will say file with the name or path, say employee data.txt. Okay. Now it will say I want to process that file with this particular MapReduce job. This will be the algorithm. One algorithm or one code or one work, or if in terms of MapReduce I will say MapReduce job. Client will submit the MapReduce job on the master. Suppose he want to do word count simply. How many words are there? Very simple example. Let's do not go in any complexity. He will say, boss, just tell me how many words was there in this 100 TB file. In this 100 TB file, I want, by the way, whatever algorithm I want to do, I'll write that algorithm in this particular job. Now as soon as client will submit the MapReduce job on the job tracker or on the master, I am having another daemon, that is name node. Name node will check, okay, yes, this client is having the sufficient privileges to process this data, or this client is the owner. Now name node will identify where all the blocks are stored. Name node will identify where are the blocks corresponding to the file is stored. Okay, name node will find out, okay, these many blocks, these highlighted blocks, suppose these highlighted blocks are there, these highlighted blocks are from that file. Okay, same in all these slaves. So what my master will does, what my job tracker will does, job tracker will send the same copy, same this task, this job, whatever algorithm code was there, the same code will travel to task tracker. The same code will travel to this slave, the same code will travel to this slave. Guys, understand, this is very important, very innovative principle. A very good concept, very important concept from the perspective of interview, from the perspective of certification, everything, even base of your MapReduce. In the MapReduce, instead of data travel, instead of traveling the data, it moves algorithm close to the data. That's called data locality. We'll discuss data locality later, but here my main objective is to how exactly it is processing the data. It will submit the same code, it will forward the same code to the slave with the notification of processing of which block using this code. Master will tell this slave, you need to process this block, you need to process this block, you need to process this block and this block. Suppose these are the say 100 blocks which I have highlighted, suppose, that are available corresponding to this file on this slave. So it will say with this algorithm process these blocks. Now what task tracker will do, it will start a child JVM, Java virtual machine. If anybody, I think all of you understand JVM, right? If we want to process anything, if we want to run any Java program, we need to start the JVM. Whenever we run any Java program, JVM come into the picture. That's why it's written child JVM, Java virtual machine. First layer of processing, first iteration in the processing, it will be the map or the mapper. Map task or the mapper will be the first iteration of processing. Whatever code we have written in the map or mapper will be run first. Understand this carefully, okay? Now just understand these are the two forms. These are the two forms or two algorithms that we write. Why? That we'll see later. Why, how, all such questions I'll answer. But yeah, I'll process the data in two phases. One first phase is the map phase, second phase is the reduce phase. That's why it's called MapReduce. Now, firstly, it will run. Firstly, my task tracker will run map task in this JVM, and it will process one block at a time. These are the blocks, guys. You can recall, right? These are the block. Now, at a time, one JVM will process one block. Suppose I am running 5 JVM. How many blocks will be processed at a time? If I am running 5 JVM, how many blocks or how much data will be processed at a time? 5 blocks and how much data? If all the configurations are default. That is 64 MB block size. 64 into 5, how much? 320 MB, correct? Correct. Gaurav, Ashwini, Venkat. If I have configured to run 5 mapper at a time, it will process 5 blocks. It will process 5 blocks. Same 5 blocks will be processed here on this slave. Same 5 blocks will be processed on this slaves. Now suppose I am having 100 blocks, so firstly it will process first 5 blocks, then next 5, then next 5, then next 5, and so on. Now guys, recall our concept, recall the definition. Master divide the work into logical pieces, that is sub work. Divide the job into task. Master divide the work into tasks. Division of work, it doesn't mean that I'll divide my algorithm. It doesn't mean that I'll divide my algorithm. No, I'm not going to divide my algorithm. The end thing that I'm processing, that is data, itself is divided. Guys, are you getting my point? The data itself is divided, so same work is coming and it is processing just one sub part of the data, one small chunk of the data. It's processing a small chunk of data here. It's processing small chunk of data here. That's why I'm saying the work is divided into logical pieces and it is processing some different small part of data. Now guys, till now I have discussed about the first phase, that is the map phase. Once the complete mapper finishes, then the reducer will start. That we'll see later in the next few slides. But till now, is everything clear? The main confusion that all of you guys were having, that map, how my work is divided, or logical division of the work, or sub work, or task. This particular running of this JVM and processing the block is called a map task. It is called a map task. The similar is the reduce task, when another JVM will run and process the data. That will be the reduce task. Map task is also called as mapper. Please note down, map task is equal to mapper. Reduce task is equal to reducer. Raj is saying so block equal to map. Rajesh, you can say processing of a block is equals to map task. Or you can say number of blocks will be equals to number of map tasks. Okay, let me clear this drawing. Let me go back and now explain you the map reduce job, one slide that I skipped. A map reduce job is the unit of work that the client want to be performed. It consists of input data, right guys? Input data, the user already submitted the data in HDFS. Then map reduce program. Then map reduce program and configuration info. Configuration info, what we have already specified in the configuration file. What we have already specified in the configuration, that's core site.xml, HDFS site.xml, MapRed site.xml, that is the configuration info. Now what is client? He creates a job, configures it and submits it to the job tracker or the master. Job tracker puts the job data in shared location and enqueues the task. If I correct this definition, I would say job tracker sends the or submits the incoming algorithm to all the slaves wherever the data is available. We have already seen the deeper definition, that's why I corrected. Now task tracker polls for the tasks. Let me go ahead. Now map abstraction. Let's understand each and everything one by one. Firstly, map. I'll give you guys a real life use case, exactly how it is processing the data, what is exactly the input, what is exactly the output, what is exactly the key, what is exactly the value. We'll take an example of one paragraph and we'll process the data in the notepad, what exactly MapReduce does in its own engine. Okay, but firstly let's understand it theoretically, then I'll show everything practically. Map abstraction. Map takes key value pair as an input. Whatever input is provided to mapper will be in the form of key and value. Key is usually the reference to the input value. Key is usually the reference to the input value, and value is the data set on which to operate. Processing. A function defined by the user. User specify his own function. User specify his own business logic in a function called map. In the mapper class, guys please note down, in the mapper class there is a placeholder or a function location where user can write his own custom logic. That's usually a map function. It is applied to every value in the value input. Whatever input is coming, the function will be applied to all the values. The function will process all the values. Now, as I told you, the input is a key value pair. It produces a new list of key value pairs. It means output is also in the form of key and values. Output is also in the form of keys and values. Output is of map is called intermediate output. Now guys, understand this. MapReduce is the complete algorithm. The first iteration or first phase of processing is called map. Second phase of processing is called reduce. The input to map is the actual input and output from the reducer is the actual output. But output from the mapper is called intermediate output. It's not the final output. We'll discuss these 2 points. That's it can be different type from the input pair or output is stored in the local disk. We'll see this. Let me show you the reduce abstraction. Again, just theoretically I'm showing you, practically in just next few slides. Just be patient for next few minutes. Reduce takes the intermediate key value pair as an input. Now you understand this. Reduce takes the intermediate input, intermediate key value pairs. What do I mean by that? The input to the reducer is the output from the mapper, or output from the mapper goes as an input to the reducer. The intermediate key value pair that is generated by the map is given as an input to the reducer. Before going to the reducer as an input, the key value pairs are sorted by the key. Processing, guys, again here in the reducer also. Here in the reducer also we are having a function that will be defined by the user. That function is called reduce function, where user can write his own custom business logic. Iterator supplies the value for a given key to the reduce function. Whatever key, whatever values we are going to get here will be processed by the reduce function. Output of the reducer is the final output. It produces final list of key value pair. Now guys, understand this. Input to mapper, list of key value pair. Output from mapper, list of key value pair. Input to reducer, list of key value pair. Output from the reducer, list of key value pair. Frankly speaking guys, whoever understands this key value concept, he will become the expert of MapReduce. Just to understand MapReduce, you should understand key and value. What is exactly the key, what will be the value, and how to handle different type of keys and values based on your requirements. Output of reducer is called the final output. It can be different from different type from the input pair. Surely input data might be in the form of say integer, and output might be in form of other data type. Output is stored on the HDFS. Exactly. Now, how MapReduce works together? Just a small flow I'm showing you. Mapper applies a user defined function to process the input data, whatever input data you are having in the HDFS. Mapper will apply a user defined function to all the input data parallelly distributedly. Mapper generates intermediate output. The reducer will accept the same intermediate output as an input. That is output of the mapper as an input. Now finally, reducer applies a user defined function to process intermediate data and generate the final output. Now let's discuss each and everything in great detail here. The complete end-to-end flow of MapReduce. Now guys, these are the three slaves. Firstly, let me explain you what is exactly the terminologies, what are exactly the things I'm using here. These are the three slaves who are represented by the dotted lines. Okay. Now for the simplicity of the figure, I am showing you just one split. So guys, one split equal to one block. Currently, please note down this. Although later we'll see a few configuration of the splits as well. But currently, one split, one block. This on, so I'm showing you three machines. These three slaves, even I should say, dotted box, three slaves. On each and every machine, there can be hundreds or thousands of the blocks are available. But currently, I'm showing you the processing of one block. Just I'm showing you to explain it in a better manner. I'm showing you processing of one block. So split 0 it's shown here, split 1, split 2. So these are the three blocks that I'm showing you here, or three splits I'm showing you here. What is exactly the split or difference between block and split, we'll see later in the advanced sections. But currently understand this as a block. That is actually the default configuration. You can see on these three machines, map task is running. This is a map task, this is a map task, this is a map task. On these three machines, map task is running. Guys, whatever we have discussed till now, whatever we have understand will be explained here pictorially. Theoretically, whatever we have seen in the slides. And this machine, this fourth machine, if you can see, this machine is running reduce task. Although guys, in my cluster there are just three machines only. Now you'll say, I can see four machines, four dotted lines. No. This reduce task will be running in any of this three node, any one of this three node. Again, for the simplicity of figure, it has been shown as a different machine so that you can understand, because reducer will run once all mapper finishes. Please note down first concept. By the way, whatever funda, whatever concepts today I'm going to give you, just note a star before that. Reducer will start. Reducer or reduce task will start once all the mapper finishes. So this reducer will be running, suppose, on the slave number 2. This. Okay, let's start from scratch. Let's understand how exactly this data will be processed. This particular block. Now, user was having a big file, again starting from the scratch. User was having a very big file. While copying the data, user copied already data on the HDFS. The data is split into blocks. I'm having, say, 100 block here, 100 block here, 100 blocks here. Okay. Now it's the time for the MapReduce. It's the time for the processing. User submitted a MapReduce algorithm. User submitted the MapReduce algorithm. The MapReduce algorithm in the previous figure we have seen traveled to the slave. Firstly, in the MapReduce algorithm, firstly the map runs. Then after that, all the mapper finishes. Once all the mapper finishes, then reducer will run. Till now, guys, is everything clear? Whatever I have told. So that I'll show you the processing of exactly one block at a time. So out of the hundreds of the block, this is one of the block. Okay. Now, guys, first point, please note down. One mapper processes one block at a time. One mapper can't process more than one block at a time. One mapper processes one block at a time. I hope you have noted down. By default, 2 mappers run on each slave by default, which we can increase to desired value, which usually we increase to certain different value that we'll see on what basis or why or how we increase that. So guys, at a time, how much data is processed if I'm having default configuration on a slave? At a time, on one slave, how much data is getting processed at a time? Correct? 128 MB, 64 into 2. Now, just understand, just imagine currently that there is a z-axis. Behind this split 0, there is a 0, 1 that is processing here. Behind this split 1, there is a split 1, 1. Behind this 2, there will be 2, 2, like that. So this block will be processed by the mapper, a mapper or a map task. Now guys, when I show you the actual code, you'll see that in a program, in a MapReduce job, if I say, it is divided into 2 classes. There will be a separate class. There will be a separate class for the mapper or map task. There will be separate class for the reducer. Let me write R for reducer. It's totally, what should I say, segregated in terms of code development. I'll write a specific code here to process my data. I'll write specific code here to process my data, a custom code. Okay. Now the map task will process, or the mapper will process this block. Now guys, let's take a very simple example to understand MapReduce. That's word count. So suppose I'm having a big file out of which I'm having one block here. So this mapper will be counting words in this. Say if you see, if I go back this paragraph, yeah. So how many times takes come, how many times intermediate comes, how many times key come, how many times slash come, how many times value come, and so on. This work, suppose this mapper is doing. Now you can note down another point. Map one mapper, this particular mapper or map task runs in a specific JVM. In the previous figure, what you have seen as a child JVM, in that child JVM, one map task, in that child JVM, one map task run at a time. So it is a specific Java process. It is a typical Java process that is running. That Java process, this particular is called map task. Now guys, this is the first location where user writes his own custom business logic. This is the first place where we have user can write a custom business logic. So there is a question, a relevant question, let me take it. Can we have multiple child JVMs on the same node? Yes, Uma, we are having. That's why I told you at a time 2 mapper runs. If you recall my previous 2 statements, what I told, at a time 2 mapper runs by default on a slave. And another statement was 1 mapper runs in 1 JVM, that's for sure. 1 mapper runs in 1 JVM. So it means 2 JVMs are running by default. Or that also, if you see this previous figure, what I have shown there, child JVM, child JVM, child JVM. That is a complete JVM only. What is a child JVM? A JVM.
Can I ask a question? Actually, if we have like, you know, in that particular blocks, let's say we have like 1,000 blocks in there, and I have, and these child JVMs are created on the fly and started on the fly, or by the sizing what we do it on the data node, or how it is? Will be specific to certain size?
Yes. There is a configuration that we need to specify in the MapReduce site.xml. Okay. So if we do not really specify any configuration, it will be started for the default size. Firstly, answer to your second question, yes, they will be started automatically. Third thing, there is a configuration in the MapReduce site.xml based on which the number of map tasks will start, number of JVMs will start. If I specify it to say, in parallel, I'm talking in parallel only. So suppose there are 100 blocks. So overall 100 mappers need to be run. But suppose my memory of the system or processor is limited, I can't run 100 at a time. I'm having suppose 8 gig system only. So I'll discuss that. We'll discuss how exactly we'll identify that how many map tasks we should run. So I can't run 100 at a time, right? So what we'll do, suppose we are running 4 at a time, 4 mapper at a time. So there will be a queue of 4 mappers will run. In the first time 4 mappers are running, that is processing first 4 blocks. Second iteration, second 4 blocks will be processed. In the fourth iteration, four map tasks, 4 blocks will be processed by 4 map tasks.
Okay. So depends on how many child JVMs we defined. All those child JVMs parallelly triggers and picks up the data and caters to the.
Exactly.
And it can cater to one single job, or it can cater to multiple jobs.
Currently we are talking, no, not multiple job. Even I'm saying not multiple mappers. One JVM can handle one mapper only. So we can't even discuss about multiple MapReduce job. There can be multiple MapReduce job, but say for example, understand it like that. I'm having suppose 5 mappers running here. Okay, out of which 3 mapper of MapReduce job 1, 2 mappers of MapReduce job 2. That can be done. I think you're asking this, right? Yeah.
Yeah. Right. Yeah. That's what I was thinking.
But if you are thinking that within a JVM I can run multiple, no. A JVM can run one map task at a time. Or a map task itself is a Java process. For a Java process, guys, we all understand for a process, we need a complete JVM. Now, if we see, guys, this particular mapper is crunching our data or processing our data, whatever logic, custom business logic we have written here. then it will write the output. The output of map task is written on the local disk. This output, what you are seeing here, what you can see in the white colored, is the data written on the local disk. Now, a big question, a good question, why I am writing my data in the local disk? Why not on HDFS?
Local disk means it's inside HDFS or outside?
No. Oma, when I'm saying on local disk, it doesn't mean that inside HDFS. Inside HDFS, it means I'll not specify this as a local disk. So local disk means local operating systems normal file, normal disk. I'm writing this particular data, this particular output.
So that's the temp space we specify in the configuration file and all.
Yes.
Temp area, there is some temp area parameter and all in the config file, right? That's the one.
No, we specified the file, the location was hadoop.temp.dir. Inside that directory, there will be another directory called MapReduce will be created. Inside that, there will be two directories will be created. Inside that, this temporary data will be stored. That we'll discuss. But first, understand this concept. The main point that what I'm discussing here. Output of mapper is written on the local disk. I'm getting some background disturbance. I think somebody left unmuted. Output of the mapper is written on the local disk. Now the big question is why it is written on the local disk? Why not on HDFS? There should be some reason. Can anybody answer this? We understand this very well. We discussed this almost 1 hour about reading and writing of data in HDFS. What is exactly is the reading pipeline? Oh, sorry, writing pipeline. How exactly I can read the data? We understand that, right? Now,
it's already read, and if you store it back, it will again follow the redundancy metrics and everything. It's a kind of overload and duplication on the system. If you keep it outside, that the reducer will pick up the same chunk of data outside and process it faster than fetching it inside the HDFS.
Okay. Rajesh is saying HDFS has a specific format. No, Rajesh, in the HDFS we can write any type of data. It's we can even store unstructured data, any type of data, not any specific format. When my own MapReduce job itself is writing the data, it can surely read the data.
Question:
storing
is that mandatory to store it outside, or it is an option to store it outside?
Yeah, I'll answer this. Let's first finish why it's writing outside. So I'm seeing the storing mechanism. No, Rajesh, when MapReduce is writing, so HDFS can also means read or write the data, the storing mechanism that will also be fine. No, Venkatesh, our master stores the metadata and slave stores all the data. So currently what I'm doing here, I'm showing you the information, this flow of MapReduce. I'm just showing you slaves only. Master, I'm not showing you in the figure. Where is Santosh, Sandeep, Mahendra? Faster processing. No. Question is why I'm writing the data into local disk. Output of mapper, why I'm writing in the local disk? Why not in HDFS? I can write output of the mapper directly to HDFS, but why I'm writing to local disk? Raj is saying to have persistent copy for that reducer. I can have persistent copy in the HDFS also. Because guys, if I just give you the next, let me show you again next thing. Output of the mapper goes input to the reducer. This output of mapper will travel from one machine to another machine. The machine where the map was run is called mapper machine. The machine where reducer will run is called reducer machine. Suppose on the third machine, the reducer will run. So on this third machine, output from all the mappers of output from first machine will go to this third machine. Output of the map, all the mappers that was running on the second machine will go to the third machine. Now again my question is same, why I am writing output to the local disk? The answer I have already given in the HDFS session. In this case there is no local copy. If you see, this data is not local to this reducer. This data is ultimately traveling to this slave. So data travel, data movement is there. Okay.
So
There are two reasons behind this. Yeah. Tell me.
Question. So the mappers, if I have 3 mappers, it is not that always my mapper will also run the reducer on the same box.
No. On the same machine only reducer is running. If you see, I'm saying on the third machine only this reducer is running. But I think
you have 3 mappers running in 3 machines, and the same 3 machines cannot run the reducer on the same data what they collected.
No, not really. Not actually. Not in the real case. What exactly the reducer is doing actually, what happens, although this would be a little early to answer, output from all the mapper goes as an input to a reducer, and I want the final output. In that case, there are chances that there is some relationship between the data available on this slave, and on this slave. That relationship will be managed here. What is exactly the relationship? In a very simple example, guys, still I'm holding this question. I'm going to another point, another discussion. Suppose, okay, I'm having a word called map. Or say suppose user. I'm taking the example of word count. What user is expecting? User is expecting that boss count the number of times a specific word come in the input file. So in this particular block, suppose the word user came 50 times. In this block, suppose it came 20 times. This output will be, okay, overall on this machine, if I say there will be 1000 times, on this machine there will be 1000 times user word. User word is here in 1000 times, user word here is 1000 times, here suppose 500 times. What I want overall final result. That will be 2500. That will be 2500. Understand this, guys, this point. So on what basis it is going, that I'm just after this slide only I'm going to show you. But that's why there are chances that there is a relationship type of this type of, although this is not exactly a relationship, but I want overall count, because if the final output, if I see that word is user and count is 1000, then again I'll see word is user and count is 1000, again I'll see word is user and count is 500. Oh, I don't want this. I want overall a word called user and overall count called 2500. If I'm running 3 reducer, 1 reducer here, 1 here, 1 here, it won't really solve my purpose. By the way, in the next slide only, I'm showing you there can be multiple reducer also. But it's a little complex. I'll come to just in the next few minutes. Again, back to my question. Guys, there are 2 reasons. Firstly, if you recall, the write pipeline in the HDFS was very costly. The write pipeline in the HDFS is costly, unnecessary. The data will be replicated on multiple machines. The first point. All of you guys, can you recall? As soon as I write any block, it will be copied to, the slave will copy to another slave, and that slave will copy to another slave. The first point. The second point is that this data, if you recall, I told the output of mapper is a intermediate output only. This output is intermediate. Ultimately, I need to delete this output. So I don't want the high availability. I don't want to put it in my HDFS, because as soon as this data is moved to the reducer node, I'll delete this data. All of you guys clear till this point? Okay. Let me again explain you. I was on the same page writing mechanism. yeah, correct. But Rajesh, I was expecting a little more deeper answers as we already discussed HDFS, but that's good. Let me again explain you guys. Input block processed by a mapper, by a custom user function, by a custom user code, custom business logic that I am writing in the mapper. Output of mapper written to the local disk. Output of all the mappers is written on the local disk. Now, the output of mapper will travel to the reducing node. You can see output from all the mapper goes to the reducer. Once all mapper finishes, then only reducer can start. Because guys, if you see the example of word count, there are chances that from the last mapper I'll get a few words. Suppose word hello. Hello word is there in the last mapper as well. So I need to wait till the last mapper run. Suppose 50 mapper run here, 52 mapper runs here, 55 mapper runs here. Till the last mapper is running, my reducer needs to wait. Now output of mapper will copied or shuffled to this slave. Now the output will be merged. Regarding this shuffling, merging, all these things we'll discuss how exactly this is done. We'll see later. This output of mapper will be merged and provided as an input to the reducer. Output of all the mappers will be merged here and provided as an input to the reducer. Reducer, again a second place. Guys, please note down. Reducer is the second phase of processing. Reducer is the second phase of processing. Reducer is the second place where I can write my custom business logic. Output of reducer is the final output. So guys, the blocks in the yellow are the data that is written to the HDFS. Output of the reducer is written in the HDFS. Who will invoke the reducer process? Who will invoke the reduce task framework? Guys, once mapper is finished, my engine will automatically invoke the reduce task. As soon as it will come to know, okay, all the mappers are finished. Yes. Once all the data are data reached to this reducer machine, then it will be it is going to start the reducer. Then reducer will process the data and write the final output. Guys, giving you 30 seconds. Please look at this figure. Then I'll explain in some other way again. If we had to count the word count of user, how will code of reducer differ from that of mapper, or where? Gotta wait for 5 more minutes. Just 5 more minutes. The logic that I told you will process will run one MapReduce job on the notepad. That will clear all your questions. So guys, whatever I have explained till now, is this clear? If anybody is having any questions, any doubts. I think Uma had one doubt. Is this compulsory to store the intermediate output in local disk, or there is a configuration to write in HDFS? Yeah, Uma, there is no configuration to write this data in HDFS. we can write this data in local disk only.
Okay.
By the way, guys, look at the now just giving few other points. If you recall, what extra feature Hadoop MapReduce or HDFS is providing? High availability, data storage, distributed data storage, what it is provided replication, what it is providing you a reliable data storage, what it is providing you distributed computing, what it is providing you automatically like data locality. All such is the feature of the framework. Understand this, how much rich is this framework. You just need to write your own custom code here. There is a function in which you will write your code here and you will write custom code here. That's it. Understand this. You are having two placeholders where you will write your own custom business logic. You will be having your own, you will be having a place, you will be having a function where you can write your own custom business logic. Rest all will be taken care by the framework. Submission of the job will be done by the user. After that, splitting of the job, where which block will be processed. So if you recall, guys, we have replication also. So suppose split 0 or block 0 is available here as well. Yeah, the replication is there in the picture. My master, while name node, while looking at my metadata, name node C, okay, name node take the decision, okay, it will ask slave 1 to process block 0, not slave 2, although I am having one copy available here. Now you'll ask why slave 1, why not slave 2? So the guys, the reason is that it has already asked slave, means it has another blocks that needs to be processed on slave 2. It's like both these slaves are same for the name node. There is no difference between the slave 1 and slave 2 for the name node. Just one thing is that if the slave 2 is already overloaded or already the tasks are running, then it will rather than putting more tasks on the slave 2, it will put on the slave 3 or somewhere else. Santosh, did I answer your question? Question was, what is HDFS application in this slide? Now, another point, when the replication will come into the picture, when this machine goes down, this machine is down. Okay, I am having data replicated. Good, I am having this data replicated here. Name node knows. Okay, yes, name node will ask this slave to process this data. Santosh, clear? Okay, good. Now, so now guys, before going ahead, I'll not explain this figure in great detail right now. Let me, okay, where is that? Yeah. So guys, I can have more than one reducer. Just one point here I need to mention, I want to mention here. Look at this. I can have more than one reducer at a time. Now you'll ask me, there are chances that the word user will come here as well as here. So I'll say no, there is no chances. I'll explain in just next few minutes only the same. But the point that I'm going to explain, I'm going to show you here is that output from all the mapper. Look at this. Output from all the mapper goes as an input to all the reducer. Please note down this point. Output from all the mapper goes as an input to all the reducer. You can see output from this map is splitted into these two parts. This division of the output data is called partitioning. That we'll see later on what basis or why this first is going here or some data is going here, on what basis it is going. Again, there is a funda of key and value that just in next 2 minutes I'm going to show you. But you can see, if you see this reducer from the reducer perspective, each and every reducer will get input from all the mappers. Look at this. So here I'm having these 3 slave cluster. Firstly, the mappers will run, and suppose on the slave 1 reducer will run, and on the slave 3 reducer will run, like that. Gaurav, output of the mapper is not in the form of the blocks. Output of the mapper will not be in the form of any blocks. It would be form of the key value only, list only. Blocks will come into the picture when you have data in HDFS. Okay, so the funda that we applied earlier, number of mappers is equals to the number of blocks. That's correct. But if you think that number of output block from the mapper equal to number of reducer, wrong. Okay, let me show you the actual processing picture of this complete thing. I'll take a real example that will clear all your doubts for sure. Now guys, leave your paper pen, leave everything else. Just concentrate here. Okay, here will the most important discussion that we are going to start now. Before that, output duplication, when would that be? Origin output is not really output of are you talking about, by the way, final output or intermediate output? Okay, you're talking about the final output. So final output, since it's stored in the HDFS, it will be always be duplicated. Just a minute. Let me go back to the previous figure. Origin, if you see here, the final output is written to the HDFS. I'm not sure whether I forgot to specify this. Whatever data is coming to return to HDFS, that would be surely be duplicated, that will be highly available, that will be replicated. Okay? Perfect. Now, guys, understand this particular problem. What I'm explaining here, understand this carefully. I'm having a requirement. I want to count the words, number of words. That is how many times a specific word came in the file. Whatever funda, whatever concepts we are learning via this word count example, everything's valid in almost all the types of MapReduce problems. There are little bit changes, ups and downs, little bit customization, all the such things are possible, but whatever things we are understanding, so understand this carefully. The first thing that we are understanding from the perspective of a word count is the application, the algorithm is word count, suppose. Now what input I am having? I am having, suppose, input data of 100 terabytes, a file of size, a single file of size 100 TB, which is split into 64 MB blocks. So my data is already stored in HDFS. The data is already stored in HDFS in the form of blocks. So suppose, guys, I am giving you a picture of one block. So this is how one block is starting. Suppose I have written, hi, this is Anish, I'm a Hadoop architect. Hadoop handles huge volume of data. Suppose this is written there. And so on. So this what I have highlighted, I'm showing you, I'm showing the representation of one block. Suppose there is a 64 MB of data. Now understand this. I'm showing you each and everything here. Input to mapper. Input to mapper. What will be the input to the mapper? Guys, what we discussed earlier, input to the mapper will be in the form of key and value. Right? Input to the mapper will be in the form of key and value. What will be your key? The key is the, please note down, key is the byte offset. Key is the byte offset of the line. And value is the complete line. What do I mean by byte offset? Byte offset means the cursor position. If you see, the cursor position is 0. Okay, so first line, the key will be 0 and the value will be the complete line. Okay, now second line, what will be the cursor position? Let's count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. The cursor position is the 17. So my 17 will be the key. 17 here, the key is 17 and the value is the complete line. Look at here. The value is the complete line. Key is the 17 and so on. Guys, since MapReduce needs everything in the form of key and value, we are having the key and value in the unstructured data as well. Although for sure this key is of no use for us. No, Uma, surely you don't know the keys. The question is, if I don't know the key, if I know only values, you don't know anything. This is what internally MapReduce does. See what exactly you know just this unstructured data, this some text. All of you guys, what I am showing you, this is the internal of MapReduce, what exactly it is doing, what exactly it is processing, and how exactly it is converting the data. We just understand this particular unstructured data. We understand this, there is a file where I have written some data, and what we want the final output that as a Hadoop word 350 times, Hive word 1000 times, Anish 25 times. I am just concerned about this too, being a user. But being a Hadoop expert, I should understand, okay, what exactly Hadoop is doing in the backend. Hadoop mapper is going to get the data in the form of key and value always. My framework will provide it. Now guys, this is the, by the way, if you are aware of different type of frameworks, say there is a Java framework called Springs. In that particular framework, you need to code in a specific fashion. In the MapReduce framework, you need to code in a specific fashion. So although this particular thing that finding out key and finding out value is not your headache, is not the headache of programmer, this is the headache of the framework. Framework itself will convert this data in the key and value, and which part of exactly the framework will do this, we'll see in the next session. That is the advanced MapReduce session. Now, guys, all of you guys, input to the mapper, is this clear? Input to mapper, one line at a time. Okay, before this, please note down one, before I ask for any smileys, please note down one more line. Input to the mapper is one line at a time, or one line is provided as an input to mapper at a time. Or if I generalize it, if I correct it a little more, one key value is provided as an input at a time. To my mapper, I'll provide one key value at a time. So guys, suppose I am having okay, let me explain. Yeah, Rajesh is asking one line, one split. No, Rajesh, not one line, one split. I'm explaining this again. I'm having input data of size 100 terabytes. 100 TB splitted into 64 MB blocks. Splitted into 64 MB blocks. How many blocks I'll be having? Thousands of blocks. Okay. Out of which I'm showing you the picture of one block or one split. As I told you initially, only one block. Please write down currently one block equal to one split now. Although the definition of split is the logical representation of a block, that we'll see later. Although so this picture I'm showing you of the one block, what exactly is happening and what is given as an input to the mapper. User has given although this plain text data or paragraph, but framework will convert this particular data in the form of key and value before given as an input to the mapper. My key is the byte offset and value is the complete line. So at a time, one line is given as an input to the mapper or one key value, as value is the one line only. All of you guys, everything clear till now? I'm highlighting this thing, what I'm expecting to be clear. I think I have explained at least 3 or 4 times till now in today's session. 2, 3, 4, 5. Okay, perfect. Now, the next thing, I got input one line at a time. I got what input? I got input one line at a time. At a time, I am having this particular thing with me. A key called 0 and value, that is complete line. Although guys, we understand this very well. This key is of no use for me. I'll ignore this key. This key just for the sake of this framework's requirement that it always need a key value. That's why I'm having key with associated with this. But this key is of no use for me. I'll ignore this key. I am concerned about the value. Okay. Before this, a question for input to the mapper. How the line will be differentiated? Venkatesh, line is differentiated with this /n. By default, there is a /n here. Right? If we press enter, it means /n. It will be differentiated by enter or /n. Venkatesh, okay? Gaurav is saying, should keys only be generated in the byte offset constraint or there are some other way? Gaurav, this is the default implementation. Later point of time, I'll show you, you will write your own key also. We'll customize each and everything. This is the default way how Hadoop works. Now, processing. Processing currently, since we are in the mapper phase, so the processing part will be the map function, the map method. Processing in the mapper, that is we specify our own custom business logic. Now guys, is this difficult for you now that if I am having this particular data with you, if I am having this particular data with me and just want to count the words, we can count it easily, right? Hi, one, this one, is one, Anish one, that's it. I can write my custom business logic. We'll see that, yeah, we can write Java code. What we'll do, we'll split this line into tokens, although there are hundreds of ways by which we can do this. We can split this line or we can tokenize this and we'll find out, okay, these are the words and each and every word I will write the count. So guys, this particular processing part is the location where we write custom business logic. What I'm getting input, I'm having data this as a this key and value, out of which I'm ignoring the key. Now I'm concerned with this value. What I want from this, I just want to count each and every word. I have tokenized this, and what output I am going to write? Output from the mapper. By output from the mapper, that is going to be written on the local disk. Output from the mapper that will be written to the local disk will be again in the form of key value. Output from the mapper. What output I'll write? I'll write one with each and everything. Hi, one, this one, is one. Well, key will be my word and value will be my count. Now you'll ask me if say for example hi word comes twice in the first line. Yeah guys, you have it's totally depending on you. If you want, you can write hi one 2 times or hi 2 1 time, because what line I have written here, this is the place for custom business logic. Again repeating guys, input to the mapper in the form of key value, key byte offset, value complete line. Processing in the mapper, process the incoming data, that is one line at a time, that is one key value at a time. Key we are not much concerned, we are interested in value. Here to process the data we can write our own custom business logic. What I'll write, since I'm having these 4 words in first line suppose, so I'll write hi is my word, count is 1, this is my word, count is 1, is my word, count is 1, and so on. Now what output I'll write now guys, again this is the constraint, this is the requirement from the framework. Output again will be in the form of key and value. Output will be again in the form of key and value. My output will be hi as a key, value as a 1. Each and every word as a key and count as a 1. Hi 1, this 1, is 1, Anish 1, I 1, M 1, Hadoop 1, Architect 1, and so on. Guys, 100% clear? Highlighted part. Input to mapper, processing in the mapper, custom business logic, and output from the mapper. I got few big smileys. That's good. If you want, I can explain again. Not an issue. Where is, I think, Sandeep, Santosh? I think these 2 smileys were missing. Okay, perfect. Now, till now it is done. Okay, we understood. Okay, first phase is done. Output from mapper is returned to the local disk. Output from mapper, it is returned to the local disk. We understood. Okay, input to the mapper. Okay, one block at a time. In this, we see go little deeper. One key value is provided as an input to the map method. It will process the key value and it will write the output. Processing is in our hand. We'll write our own custom business logic. Output again written in the form of key and value, but output is written on the local disk. Now, guys, next concept is very, very important. Most important point here. On what basis which data goes where? The point is what input to the reducer will go. All the values corresponding to the same key goes to the same reducer. All the values corresponding to the same key goes to the same reducer. Now in this case you can recall our funda, yes, what we discussed earlier here in this previous figure. Here I am having user word 100 times, here 100 times, here 500 times of what I took earlier, 1000, 1500. So what final output I want? 2500. So guys, all the user word, since user itself is my key, this word itself is my key, so all the values corresponding to same key, all the keys corresponding to user will be given as an input to the same reducer. The same thing I'm explaining here. So what will be the input to the reducer? Input to the reducer will be again in the form of key and value. Here my key will be the same, what the output key of mapper, that is word. Suppose word is Hadoop, and value, all the values corresponding to key Hadoop from all the mappers. Suppose I am having 1000 slaves in my cluster, and in those 1000 slaves overall 1 million mapper runs. Overall 1 million mapper runs. So this will be the output from all 1 million mappers. In whichever mapper Hadoop key came, the value is highlighted here. All of you guys, is this clear? 100% clear? If you want, I can explain in other ways also. Should I explain it again?
So the number one in the Hadoop, if it is like 200 times it is there. So 11111 it will be there 200 times.
Correct.
The value. So
if it is 1 million times, then there will be 1 million times 1111111 will be there.
So when will 2 comes? When will 3 comes in Hadoop? So
no. If you miss, I think what I told you. This is the custom business logic, right?
Right.
Whatever we want, we can write output. My main work is that here framework has given you this line. Framework has given you this line. You want to count the word at a time. This line is there with you.
Correct.
Whatever way you want to process, you can process. Whatever code you want to write, you can write.
No. If
say for example, you have written a particular
data node.
Listen to me. For a particular, say for example, you know what input you are going to receive. Now, whatever code you have written in the map method, the same code will be applied to your 100 TB data. Suppose there is 100 million lines. Getting my point?
Okay. Oh, so yeah. I got the point. No. The question is, I'm asking in the data node level how the data will be submitted to the reducer. You gave an example that user word 2500 times and split across 3 nodes. Okay, one node is processing, one node user is showing 1111,000 times, and another node also shows 1111,000 times. Another one node also shows 1111,000 times. Is that right?
Yes. So
all the ones goes to one place.
No. Let me correct you. Corresponding to a specific key, all the values, whether that is a 1, whether that is 2, this goes to the same reducer.
So explain me in what case 2 would come. In the sense that if I'm searching user.
I am Hadooper. Can you write 2 here? Hadoop comma 2, high comma 2 here in this single line?
Yeah. So that is one line, how many times it is occurring? That's what it is.
It is totally your custom business logic.
Okay.
If you want, you can write here also. You can write the same thing here as a high comma 1, high comma 2 times. My question, how many? I understood. You are saying when the 2 will come, when the 3 will come, more than 1.
Right. So
you are not getting.
No.
Yeah. Go ahead. First you can finish it, then I'll answer.
Because we said that is the initial key value. So 0 is starting of the page and starting of the line. From there onwards, it started counting each line, and in the one line, if we get like 2 highs, for example, it will be key is high and value is 2. Is that right?
Yeah.
If it is more than 2 in one line, it will be done once the line is broken into second thing. Then it will next line, next 2 comma 1 2 comma like if it is next line, it is 1 is there.
Don't go in wrong direction. No, don't go in like that. Suppose, let's make it as simple as possible. Let's make it very simple. Suppose, don't go for 2 even. What I will say, think about 1 1 only. 2 times I am getting high, make it 1 1 only. What I'm saying here, okay, I am a Hadooper. Hello world को let me write hi world. How many times high is there?
4 times, 5 times.
5 times high is there. Now at a time, this thing you are getting as an input.
Entire
One
thing.
line. This is one line for you currently. Imagine.
Okay.
Okay. Now this is based on being you as a developer, being you as a programmer. If you want, you can write hi, comma 5, or you can write hi1, hi1, hi1 5 times. This is in your hand. You are having Java code with you. The place where you can write. The default implementation of word count that is shipped with Hadoop, usually it writes that the default MapReduce job, by the way, there is an example that is shipped with Hadoop. It writes 1 for each and everything. Now, let me correct your question. What exactly should be? The question should be, although it would be very early to discuss this, why I am sending Hadoop, 1, Hadoop, 1, Hadoop, 1000 times from here to here? Why I am sending Hadoop, 1, Hadoop, 1000 times from here to here? Can't I write Hadoop, 1000 just one time?
Yeah, that's what
Can't
my
I do
question
this?
is.
Why I am sending 500 times Hadoop, 1, Hadoop, 1, Hadoop, 1, or user, 1, user, 1, user, 1, or even any word, 1. So guys, there is a provision for the same also. For that, we'll write another thing here that is called, let me put a point here, at this place we'll write combiner. That we'll see later.
Okay.
Guys, whatever I have explained till now, input to the mapper, processing in the mapper, output from the mapper, till this everything clear? Rajesh is asking, I just missed reducer part. How many reducer will be there for a given job? No reducer, no Rajesh, we didn't really discuss till now how many reducers will be there. What I'm explaining, what is exactly the input to the reducer. By the way, number of reducer usually either we can configure, we can specify, say for example, I want this many reducers, or framework itself can decide the number of reducers. There is a very small formula for the same that we'll discuss. But how exactly the input to the reducer is provided? How I'll not get the case that the same word is emitted from here and the same word is emitted from here in the final output. In the final output, I shouldn't get Hadoop, 500 from here and Hadoop, 1000 from here. All of you guys getting my point? I want either all the Hadoop counts here on the reducer 1 or all the Hadoop counts here at the reducer 2 for the same. The thumb rule is this. The input to the reducer will be in the form of key value. But what will be the key? Key will be the same. Key will be the same, the word. But the value will be all the values corresponding to same key will be given as an input to the reducer, same reducer at a same time. So what example I was giving you guys, my key is Hadoop and this key was there in 1000 or say 100,000 mappers. So from all those 100,000 mappers, or from say 500 slaves, from all 500 slaves, it is going to reach to the same reducer. All of you guys 100% clear? This is very important concept. This is very important funda. Because if you understand really this key and value concept, you understood the MapReduce. Apart from this, if you see, say for example, you write custom business logic, this is your place. You can write whatever Java code you want. Again in the reducer processing, again it would be your place. You will know, okay, what Java code you want, you can write. But what exactly framework is providing you? Now framework has given one key value at a time you in the reducer. That is Hadoop and all the values corresponding to Hadoop. What will you do in the reducer? What processing you will do in the reducer? Can anybody tell me what processing you will do in the reducer? Correct.
Consolidate.
Perfect. Santosh. Sum. Correct, Gaurav. Add all the values. Add the values for each key. Correct, Ashwini. So sum all the counts. Sum all the counts. That is sum all the 1, 1, 1, 1. Suppose this is 350. I'll simply sum all the counts. I'll simply add up all these ones in the values, all these integers in the values. And what output I'll write from the reducer? That would be, by the way, the final output. Output from the reducer. Final output. Output from the reducer will be the final output that is going to return in the HDFS. Output from the reducer again will be in the form of key value. Key will be my word and value will be the final count. Hadoop 350, Hive 1000, Anish 25, so on. Now guys, if you recall our initial objective, initial agenda, what exactly we started? Word count. That is count each and every word, how many times its occurrence in the file. And what output finally we got? The same. All of you guys, 100% clear? Just even not 99.99. The complete flow. One, two, three. This time I want smileys from all of you guys. Let me figure out if anybody is not really following. Sandeep, is this clear? Okay. Who else is remaining? Origi is asking, output from the mapper looks like programming plays a major role generation of the same keys. Origi, output, if you ask for the output from the mapper, if I give you very simple way, let's not go in that much detailed discussion, just very simple, very easy way, just that we clear it. Suppose it depends on your requirement. Firstly, what will be your key and what will be your values. Okay, in my case, in this particular case, since I want to count the words, that's why I am writing this key as high and value as 1. Key as high and value as 1. Getting my point? What exactly I'm doing here, I'm processing this particular value. I'm processing this particular value in the mapper. Now I know output what I need to write will be in the form of key and value. If I write key as high and value as suppose 1, if I take this key, means why I'm taking high as a key, because of this particular point. Orich? Because from all these mappers, I'm going to get this key and all its corresponding value at the same reducer.
Yeah. One of the doubts what I was having is like, I mean, for different types of data, like this is simple data wherein we have straightforward words. Like let's assume if we have data in different formats, like how do we really do the programming? Like, I mean, is there any specific way which is mentioned, like you have to generate for this type of data in this way, or it can process any type of data, as you said?
Yeah, good question. Firstly, the answer to your last question, it can process any type of data, firstly. Now, second, what is is there any rule or anything for this generation of this key and value? So it depends on your problem. It depends on your requirements. Why I'm generating this Hive word as a key and value as a one? It is my requirement here. Let me give you a simple, very small question, very small task. Just do it right away. That will clear this one much more. Now, guys, I'm having a very big file. I'm having very big file. Okay. All of you start doing this particular thing, this particular assignment you need to do right away. I'm extending session a little bit. Just if anybody is in hurry to leave for the day, leave for the office, no issues. You can leave. We will discuss the same tomorrow if you want. So guys, input data. This is the input data. This is the input data. Numbers. They are separated with the space. Input numbers, they are separated with the space. What final output? This is the actual input, initial input. What final output I want is the sum. Suppose this is the sum, final sum. You need to develop similar MapReduce template, similar sections. That is, this is your input. Okay, you can write numbers here. What will be your input to the mappers? Write like this. What will be the processing in a mapper? Write like this. Just separate your each and every section with a star or something. And I want the complete flow till the final output. Here in this case, final output, what I want is the question clear, all of you? Meanwhile, you finish this task, I'll resolve others' doubt. All of you guys, is the question clear? The question is to sum all the numbers in a file of size 100 terabytes. I want the sum finally, just simply sum of all the numbers. Although it's looking very simple, but it's not that much simple. There is one trick. If you understood the funda of key value clearly, you can easily solve this. Is the question clear, all of you? Okay. Now let me take few more questions. Rajesh, I don't know my questions valid or not, but why only key value format for all the solution? Rajesh, this is the requirement from the your framework that we need all the data in the form of key and value. Now, again, there is surely a logical reason why. All of you guys understand this. Why I'm having all the things in the form of keys and values only. Why not without key value? So guys, there are chances. If you see, if I do not have key value for the word count, if I do not have key value funda for the word count, how will I make this valid, this particular thing? This is very important to count the word even. Word count is very simple. How will I make this happen that if there is any relationship between the two records, understand this, if there is any relationship between the two records and those two records are in two different blocks, one record in block 1, one record in block 2, how will I handle this case? Because I want these two records, the record, suppose record number 57 here and record number 109 here, they should go to the same reducer because I want to process them together. Rajesh, getting my point? Now, if we take another another point, if you observe this key and value, although these are getting provided, we are providing these keys and values. If you think that I can't solve all the problems with this key value, we can solve keys and values problems also. That is not having key value. If you see our example, this is plain text. This is the most generalized data. This is not having any structure. This is purely unstructured data. Where also here itself also, I am having this keys and values. I am having this keys and values automatically generated. And another point is that if this key is of no use for me, I'll ignore this. I'll simply ignore this. And if you think you can't really create a logical keys or really key and values are not really needed, there is a funda of using null. That is null writable, by the way, that we'll see later exactly in the APIs. But there is a funda for that. Will not use this key value funda there. We'll simply use null there. That's called null writable. So, Rajesh, clear? If you guys are answering the task that I have given, guys, rather than answer right away, please prepare the same in the notepad. If you keep pinging, actually your notepad will be very long to prepare all these actions. Santosh is saying, can I customize the separator that is instead of slash and oh yeah, Santosh, surely we are going to do the same. This was very simple example. Let me give you a few other examples. Say for example, I am having XML. Suppose I am having let me take the example of this our property files, that core site.xml, suppose configuration file where we are having properties. Okay, property, then slash property. Here I am having say name, I am having say value. Okay, here I am not having this line as my record. This slash n is not considered as my record. Here for me the record is this complete line, this complete record from property to slash property. We are going to see that as well. All such type of customizations are possible. Okay, Santosh? Rajesh is asking what kind of solutions can we provide using this framework. Rajesh, it can solve any type of things, any type of problems. Even I shouldn't use the generalized word. Almost all the types of problems you can solve. Still, I think you are a little bit confused with this key value. It's making the thing like for you is like I can solve very limited type of problems that are actually in the form of keys and values. But Rajesh, it's not really like that. Look at this problem. Look from another angle. This particular problem is simply a summing of numbers. Neither there is the input data is in the form of key value, neither output data is in the form of key value. We can solve this problem also with the MapReduce. Rajesh? Say for example, you are having employee data like employee ID, employee name, employee department, employee salary. And you want to count, say for example, how many employees from a specific department who is having their salary greater than a specific figure. You can do the same. Okay, that's good. Venkat is asking, while I'm running sudo apt-get update in Ubuntu, I'm fetching error in field. Yeah, Venkatesh, you will get this particular error in Ubuntu if you run sudo apt-get update. If you have changed your network adapter to from NAT to host only adapter. Let me show you that. Oh, come on. My system is a little slow now. Oracle VM VirtualBox. So Venkatesh, go to settings, go to network. Look at this. Make it NAT. Make it NAT so that it is going to use the network of your own host machine, internet of your host machine. If you are using wireless router, if you are using say any router, you can use bridge adapter. Your virtual machine will get IP address from the bridge adapter. Your virtual machine will get IP from your router. If you use host only adapter, your IP will be local to your this machine only, and it won't be having. Your IP will be local to the machine, and you can access this IP from your host machine, that is from Windows machine, but you can't access net with host only adapter. Let me close it. I'm using Ethernet cable broadband. So try for bridge adapter if you get the correct IP with the Ethernet one. If you get say IP like similar to what you are getting in your host machine. If not, go with NAT. With NAT you install, do sudo apt-get update, install Java. Then after that, what I have shown you previously, then you can install Java. Then again go back to the host only adapter. And if still error persists, let me know. So tomorrow before starting this session, I'll resolve this issue. I'll make it the present and let's resolve this issue. From user, somebody answered the complete thing. Ashwini answered the complete flow. That is input to the mapper, out processing in the mapper, output from the mapper, output from the reducer. Complete thing he answered. But Ashwini, you tell me, the answer you have given, is this correct? The final output I am expecting is this. That is a single number. Output what I am expecting final is just a single number. And you are giving me n number of keys and values. This final output means output from the reducer. Anybody? Sure guys, take your time. Giving you 3 more minutes to think about it. It's 9:03. Let me mute myself. Okay, I got few more answers. Let me read. Okay, Uruj. Input to the mapper. Okay, processing. Output from the mapper. No, Uruj, how we'll get the answer? Say input to the reducer, what input to the reducer you are getting, or what output from the reducer you are getting. So I want this final sum of all the numbers. You understand the distributed nature of the framework. So this is not just a single block. I'm saying this will be the data will be of 100 TB. Suppose huge data. Okay, there will be suppose thousands of the blocks, thousands of the machines, thousands of the blocks. they are processing the data, and if you choose this key, this won't give you the right answer. Think more, going in little, just you are choosing few things wrong. I have passed the whole data, then processing, I'll get all the digits in this space, then some. No. Think more. Ashwini is saying output is 307. Ashwini, I'm not concerned about the output. I'm saying just show me the complete flow. Complete end-to-end flow about input to the mapper, processing in the mapper, output from the mapper. Input to the reducer, processing in the reducer, and final output from the reducer for this simple problem of summation of numbers. Guys, giving you 1 more minute. Meanwhile, let me create few placeholders where I can write specific things. Input to the mappers. Okay. Processing in the mapper. Output from the mapper. Input to the reducer. And final output from the reducer. Processing in the reducer, sorry. And final output from the reducer. That is what is exactly your output. I got one more answer from Rajesh. Input to processing in the mapper. Output from the mapper. No, Rajesh, think a little bit more. Firstly, there are lots of still things are wrong. Okay, let me take Gaurav's. Oh my God! Appreciate Gaurav the things that you have chosen. Appreciate this. Means, guys, there is a the challenge that you are the guy is presenting in front of you. Gaurav, student have solved the problem correctly. Appreciate this. A big smileys, big applause from my side for Gaurav. Still, there are guys senior who are more than 20 years of experience here. I'm not comparing, I'm just giving you a challenge. Think about it. Think from different perspective. If you understood all the funda clearly, whatever I have given you in the word count program, word count problem in this particular MapReduce template, you can easily solve. You can easily solve the number sum. This number sum problem. Where is Uma, Uruj, Santosh, Sandeep? Aditya also answered. Let me see. Okay, good. But one thing, Aditya, you missed in the processing. Think more. what you are doing in the processing. Although you answered really correct, means appreciate again another student, guys. Aditya is also a student. What you have done in the processing, think more. Okay. Perfect. So I got one correct perfect answer, I should say, from Mahendra. Okay. So again, a balanced fight between seniors and juniors. Guys, I got 3 answers. I'll consider all 3 correct. Just one, there are few small mistake that I'll make it okay. No issues that I'll rectify here when I explain. So, expecting one more answer. Uma, Uruj, Rajesh, Santosh, Sandeep, Ashwini, all the senior guys. By the way, Mahendra, just one question. How much experience do you carry? Okay, 19 point something. Okay, fine. Alright guys, please stop. Please look at here. Understand carefully what decisions I'll be taking while choosing keys, values, processing and all. What will be the, okay, this will be my actual input. I'm showing you this as a data of a specific block. Okay, what will be my initial input? Okay, input will be key, input to the mapper will be the key 0 and value, the byte offset. Second values, okay, let me count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 will be the key and value will be the complete line. Okay, what processing I'll be doing in the mapper? What processing I'll be doing in the mapper? I am having this recorded time, out of which I'll consider just my value. I'll consider just value here. Simply sum. What I'll be doing here? Processing in the mapper, I'll not doing any counts. Some of you were doing counts. I'm not interested in the count. Suppose the output is, suppose this sums output is, suppose 3, 6, 1. Suppose. What will be the output from the mapper? What should be the output from the mapper? Some of you are writing say 34 is the key and value is 2 since 2 times 34 is there. Value is 3 since 3 times 34 is there. Some of you are writing say 361 as the key, this sum. If anybody can sum this for me, by the way, so that I can use the exact figure. 34, 3, 4, 34, 4, 34, 3, 4. So that I'll use the exact figure. So some of the guys are using the final sum as the value, as the key. Guys, as I told you, this key value format you need to surely follow. You need to follow. Okay, 113. Thank you, Aditya. This key value funda you need to follow. Okay, Somebody answers 120. Let me take it 120, suppose. Okay. But to choose a key, you should firstly understand what final output you want. Final output I want is the sum of all the numbers. I need to choose a key so that all the sum of each and every line will go to same reducers. If you understood this particular line, please note down this line. By the way, you have already noted down this line. Put a 5 stars before this. By the way, guys, during the complete sessions, I'm going to give you merely 5-7 concepts that will be 5 star. Although thousands of concepts will be just 1 star. Just 5 star concepts are very rare. So this particular funda, all the values corresponding to same key goes to same reducer. So what key should I choose? Let's choose a dummy key. Say for example sum. I'll choose sum as my key 120. Next line my key is same. Sum suppose 340. Next line sum suppose it's 110. All of you guys, what I told you, this is in our hand. This processing, this output, everything is in our hand. Based on our requirement, we can choose this. If I choose sum as the key, what I am going to get here in the value in this reducer, I'll get the values as a 120, 340, 110, so on. Okay, is this clear, guys? All of you. If I choose different key, if I choose something else, if say for example if there is more than one key, suppose there is more than one key, sum 0, 1, some values will be given as an input to this also, and I'll get final output will be sum and one value, sum and some value, and sum 0, 1 and some value, suppose val 2. I don't want this. That's why I have given a consistent key. My key is common for all the data, for all the processing in all the mappers. From output of all the my key is same. That's a dummy key sum, and values will be the sum of each and every line. Now what I'll do in the reducer, simply sum all the values. Simply sum all the values. Now what output I'll write? Suppose the sum is say 5, 6, 7, 9. Suppose this is the sum, final sum. So what will be now my output? My output will be this. Now you'll say your final output will again in the form of key and value. I'll say yes boss, it will be again in the form of key and value. But can I make my key null? What I told you earlier. While sending, if I make my key null, that's null writable, although I'll show it later. So what will be my final output? Eventually it will be just this value. Guys, the best way I can explain the complete flow of MapReduce. Here the main decision was this, and the main line that you should understand is this. The connect between map and reduce. All of you guys, 100% clear? If I can get a smiley. I keep asking for smileys.
Can you send this? Can you send these text?
Everything will be there. Everything will be there in your LMS in just next few minutes.
I'm not a programmer by experience.
I understand.
So
I understand. Just that's why for you guys, just I'm asking. Write logic.
I'm trying to understand the logic.
End-to-end logic, and just write it in the notepad.
Sure, definitely. And tomorrow, do we have class?
Yeah. So tomorrow it's a new year. We are surely having a class, and we'll be having a long session. Be ready for that.
Man, Your New Year morning is my New Year evening.
Yeah.
31st evening. Yeah, you'll be the year ahead.
So guys, all of you be ready for our New Year session. So New Year, let's do something different. Usually people enjoys. We are going to enjoy MapReduce in the New Year. Ready for a long session in the New Year. Sir, yeah, Gaurav, we are about to close. You can leave. I can understand, guys. We have extended our session quite long. So I got big smileys from Ashwini, Gaurav, Santosh. Okay, great. Perfect. So guys, you will be getting all this recording. I'll ask to upload right away only so that you watch this recording. All these templates. Apart from that PPT, everything will be there in just next few minutes in your LMS. It's highly recommended. Please go through this recording before tomorrow's session, because tomorrow we are going ahead from this and we are going to take one real life example. That real life data we are going to see, and we are going to process the same using the MapReduce. So guys, let's discuss these things more tomorrow. Okay, let's close for the day. I need to. Okay, Rajesh, go through this and we'll discuss this on tomorrow. What is our gift for the new year? Okay, wait for tomorrow. All right, guys. Thanks so much for the day. See you tomorrow, same time. Have a great day ahead.